Okay, welcome Linda and Sean and Claudia and Stephanie. This is the week 6 webinar. And what we're going to be doing today, the main piece of it is confidence intervals. It turns out that the first 5 weeks of the class, I mean, they're important and nice, but it's from now on where it becomes really, really useful. So everything we do now, I'll be able to, easily find some kind of news piece that's got whatever we're doing, okay, or research piece without any issue. We've already talked about the normal distribution of the central limit theorem, and now we're going to start really using it. So that is the plan. We'll talk about confidence intervals for proportion. We'll talk about confidence intervals for mean, and that is going to be something that we're going to pretty much break the class into 2 pieces. One is quantitative, and the other is a yes/no question. So most of the questions from now on are going to be one or the other. The other thing I'd like to do at the end is talk about the project just a little bit. We're not ready to understand all of it, but we're ready to start thinking about it a little bit. And then next week we'll be able to understand most of it, and the week after we'll understand all of it. So that is the plan for the day. And don't forget to ask questions or join in if you do have any questions that might happen. So are there any questions before I start on up? Any questions? Okay, so thanks, Dom, and thanks, Morgan. Dominique, I guess. Dom. Dominic. So let me just get to the material and talk about why we care about confidence intervals and what they're about. So the idea of most data collection is you can't get the entire population, and hopefully I've gone over that enough times to know that you can't. So I'm going to mute you just because it's a little noisy. But you can't get the entire population, so you get a sample. And when you get a sample, your sample has a mean or a proportion, depending on whether it's yes, no, or whether it is a quantitative question. And you get a number, but the question is this representative of, is it a good guess or a good prediction for the population? Because that's what you always want. You want to find out what the population is. You never can. So you use a sample to make a guess about the population. Okay, so that is what we're all about in this class, actually. And what we're going to do today is we're going to say, well, we have this guess, which is the sample mean or the sample proportion. And now the question is how good our guess is. Are we way off? Are we really close? How good a guess is it? And that's really important, because if you have a terrible guess, then it's useless. We already did in the first chapter talk about bias. So the idea is do everything you can so that there's no bias, but then there's still going to be error, because just there's random error. If you ask a bunch of people, then that group of people, just by chance, might not be like the population, even though you did your study just perfectly. That's just the way it goes. So I thought I'd start out with a current event. And I like Gallup because it gives you some information, which is always good. It gives you the information we're going to need. So I'm going to share my desktop, and we're going to read a little article, and we're going to talk about what it means. So let me go to share screen. Let me go find it. And did it share? Do that. Yeah. Okay, so this is a little Gallup article. And Gallup does a Trump job approval rating. Okay, kind of important, especially if you're interested in who's going to win the next election, right? So we have a Trump job approval rating, and what they've got is they do it every week, and I want to just look at the most recent. To me, that's the most interesting. And you'll look at, in green is the approval. So let's look at how many approve. So we have 40% of the nation, okay, or at least the people who responded, approve. So the question is it true that 40% of all Americans approve of the job that Trump is doing? What do you think? You can put in your chat box, or you can say it. So what do you think? Do you think it's true that 40% of all Americans approve of the job Trump is doing? And let's see what you guys think. So what do you think? I don't see anyone type in the chat box, but you should be. The yes or no. Okay, so not all Americans, so they can't ask that many people. Okay, no, because they're testing all the population. Exactly. I know that they don't know. And the way I know for sure that they don't know is they didn't ask me. And my guess is they didn't ask any of you either, did they? Okay, so this 40% is just a guess. So do you think it's likely that maybe fewer than 50%, because that might be interesting, that fewer than 50%, less than a majority, think that Trump approve of Trump's job? Do we think that we could be pretty confident that of all Americans, it's less than 50%? So let's see if you change your mind, or if you think it's still, you really have no clue at all, or do you think it's really likely? So what do you think? Put in the chat box and we'll talk about it. So you think it's not likely that fewer than 50%? That's what Linda says. Claudia's a maybe. Claudia's still a maybe. Could be possible. Okay, so let's look at what they've told us. And what they told us down towards the bottom is right here. The margin of error is plus or minus 3 percentage points. That's important. So that's important. The margin of error is plus or minus 3 percentage points. What that means in this case, and we'll talk about even more detail in a bit, is that we could be 95% confident that the percent of all Americans who approve of the way approve of Trump's presidency is somewhere between 37% and 43%. Any idea on how I got those numbers? 37% and 43%? So anyone know how I got 37 and 43? Yeah, I subtract and add 3 from the sample proportion. The sample proportion was 40%. If the margin of error is plus or minus 3%, then if we go down 3% from 40, you get 37%. If you go up 3% from 40, you get 43%. So we could be 95% confident that the approval rate for the whole country is between 37 and 43%. So it definitely looks, I think we could be very comfortable that the approval rate is less than 50%. Any questions on that? Because if we're 95% comfortable that it's in between 37 and 43%, we're still way below the 50% marker. Do you see that? So this kind of what confidence interval is all about. It tells you you could be 95% confident, not at exactly 40%, but in some range. And the margin of error tells you how far up or down to go from the range. Any questions on that so far? Okay, so now what I want to do is I want to do the calculation. Okay, and let me see if it really is plus or minus 3% for the margin of error, according to our calculation in our class. Well, the first thing is we have 1,500 national adults. So I'm going to show you a few things. I'm going to keep that in mind, 1,500 adults, 40% plus or minus 3%. I'm going to write that down so I don't forget it. So 1,500, 40% plus or minus 3%. So now what I'm going to do, and the plus or minus 3% we'll use in a little bit, or we'll check. So I'm going to reshare my desktop, and I'm going to go to Paint so we can start working on this out. Okay, so what I could do is, and you should be used to this by now, is I'm going to sketch a little diagram. So first thing is that we have a large sample size. 1,500 is large, and notice 40% of 1,500 is well over 5. Do you agree? So that means that we can say that the distribution, the sampling distribution, is approximately normal. That was what the central limit told us for proportions. So let me write a couple things in just to check, because I'm going to need it anyway. So NP is equal to 1,500 times 0.4. And 1,500, 40% of 1,500 is 600. If I did in my head right, and I think I did. NQ is equal to 1,500 times 0.6, and that's 1,100. Both are bigger than 5. By a lot. So that means the normal distribution is a very good approximation. No issues with error because we're so well above this 5. Not a problem to use the normal distribution. Okay, so the normal distribution tells us, first thing, that the mean of the distribution is 0.4. So that's a mean proportion of all possible samples is what we're using. Any questions on that? The standard deviation, if you remember, we call that sigma sub p hat, is, oops, is not that was a mistake. Try one more time. Is equal to the square root of PQ over N. Any questions so far? Any questions? Now, I don't necessarily need that right now because the calculator is going to do a lot for us, but just to remind you that we have a normal distribution. And what we want to do is we want to say, well, what interval on the normal curve will give you 95% of that area? Any questions on that idea? Okay, when we find that interval that gives us 95%, that will give us a confidence interval. The distance between the 0.4 and that value to the right, or the value to the left, it really doesn't matter because it's the same distance, because there's symmetry. That is called the margin of error. Any questions at all so far on the picture? I think the picture is important. We're not going to be seeing the picture that much, but this ties in everything we've done. And we know, again, we have a normal distribution because of central limit theorem for proportions. So now what I'm going to do, the next step, is I'm going to use my calculator. So I don't have to do all the calculations little bit by hand like this PQ over N and stuff. The calculator is going to do that for us. But I do want you to understand the picture and what just happened. So we're going to find out these two values. Maybe I'll type in, I'm just going to call it L for low and H for high. Low. Actually, how about U? Lower bound and upper bound, because I think that's what the calculator calls it. And we want to find L and U so that we can get this interval that is 95% likely to contain the population proportion. Any questions on that idea? Okay, so now I'm going to go to my calculator. I'm going to do new share. And I'll show you how to do that with proportions. It's quite easy. So what I'm going to do is I'm going to go to stat. I'm going to go to tests. Okay, this is the first time that we've gone to this tests. And I want to let you know there are a lot of tests. You could scroll down a whole lot in your calculator and on 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 and on. That's the rest of this course. That's what we're going to do for the next 6 weeks, is we're going to learn about all of these tests. So today we're doing a couple of them. So the one I want now is one prop Z test. The one stands for there was one survey question with one group of people in the sample. The survey question is, do you approve of Trump? And the group of people were those 1,500 people. Prop stands for proportion, because we're interested in the proportion of people who approve of Trump's job. Z means that we checked NP and NQ. We got 600 and 1,100, and they're both bigger than 5. Okay, now we're not going to use test, it turns out. That'll be next week. We're going to use the one prop Z int. So int stands for confidence interval. So the int is for confidence interval. Test is going to be next week for hypothesis testing. So let me ask you, are there any questions about why I chose one prop Z int before I hit enter? Okay, I'm going to hit enter. And it's very easy to use on this calculator. X is going to be the number of people who said yes. Now, we already calculated that. Remember, 40% said yes. 1,500 were asked. So 1,500 times 0.4 was 600. So that was 600. N is the sample size. That was 1,500. Sea level, nothing to do with how many feet above, the ocean you are. This is confidence level, is what we call it. And that is 0.95 for this example. It turns out that 0.95 is what all news uses. Okay, that was set up in, I believe, the 1930s, a long, long time ago. And the funny thing is, the New York Times, not mathematicians, but the New York Times are the ones that decided on this. And in those days, New York Times ruled in terms of news. So everyone went with it, and that's what we've gone since. Other places will use a different confidence interval, but news always uses 95%. For example, our Forest Service up here, when I consulted for them, they wanted 90%. So if you're more confident, that means that you're going to be right more often, but from the picture, from the normal curve, if you want to be more confident, you're going to have to widen your interval so that you can collect more area. So you can be more confident, but your interval is not going to sound very good, right? You could be 99.999% confident that somewhere between 1% and 99% approve of Trump. But that tells you nothing. Does that make sense? You could be 2% confident that somewhere between 39.9% and 40.9% approve of Trump. But to be 2% confident, I hope you're not okay if you're wrong 98% of the time. Okay, so we're going to be 95% confident because the news is established they're okay if they're wrong 5% of the time. And that's what that percent confidence talks about. I'll be more, give you more detail later. Then I just hit enter and calculate. Now there's our interval. Okay, not that different from 37 to 43%, which is what Gallup said, but actually it's not the same either. It's 37.5% to 42.5%. Okay, so Gallup I've learned they tend to be a little bit more conservative in their rounding so that they don't get in trouble, basically, is my guess. I'm not sure, but that's my best guess. So what we can say is that the confidence interval is between 37.5% and 42.5%. That could be a little more accurate. So let me reshare. And let's write down the conclusion. So the conclusion is with 95% confident, it can be stated that between, and we had 37.5% and 42.5% of all Americans. Notice we're not talking about the sample anymore. Now we're talking about everybody. Approve of Trump's job. Approve of Trump. Any questions on that? Any questions? Okay, and that all comes from what we just did with the normal curve. This is all central limit theorem. The calculator just did that calculation of what we have in the picture. So I want to mention something, but I'm a little fearful because students have trouble with this. So if I ask you, what is the conclusion? It should start with whatever percent confidence. So I want you to tell me, and those on video, you need to pretend you're telling me. I want you to put in the chat box, yes, when I ask you to state your conclusion for a confidence interval, will the first few words be with blank confidence, where blank is your percent? I want you to put yes in the chat box. All of you have to do that. Okay, so that's a promise. Okay, because I will ask you to state your conclusion in the context of the question, and you need to say that. Okay, it won't be about Trump, okay, every time. This is just an example. But it will start with two of the first three words will be with and confidence, and the middle will be whatever percent you're dealing with. The reason why I'm saying this over and over again is when I give this on the exams, and it will be on the exam to state your conclusion about the confidence interval, a lot of people get confused because they write the next piece. So the next piece is interpret the confidence level. Which is very different than what is the conclusion. So interpret the confidence level means, what does it mean to be 95% confident? And the picture helps us a little bit. Remember, this is a central limit theorem picture. So it talks about not this sample, but all possible samples. So if Gallup went and did this sample, and then tomorrow they did another sample, and then they had 1 million different people doing more samples of 1,500, then the idea is they're going to get these confidence intervals. Each time it's going to be different, right? If you ask a different 1,500 people, you're not going to get 40% again. You might get 39%. You might get 28%. You might get 41%. Does that make sense? So if you do a sample, you're going to get a different percent each time. And every time you get a sample, you're going to have an interval for the confidence interval. Now, there is a true population proportion. And I like to think of Gallup being a winner if their confidence interval got that population proportion, and a loser if it didn't. Does that make sense? So you're trying to win. You're trying to get the population proportion, but you never know if you won or lost. You just hope you won. But what we can say is that if Gallup does this survey over and over and over and over again, 95% of the time they'll be winners. 95% of the time, their confidence interval will contain the population proportion. and 5% it won't. So let me write that out. So if Gallup conducted many surveys of 1,500 Americans, then each survey will result in a different confidence interval. Right? The one they got this time, right, according to our calculations, was 37.5% to 42.5%. Okay? If they did it again, they're going to get a different percent. All right? We don't know for sure whether the true population proportion is in between 37.5% and 42.5%. But what we can say is that of all the possible surveys that they can do, 95% will result in a confidence interval that does contain that proportion, the population proportion. So 95% of these confidence intervals will contain the population proportion of all Americans who approve of Trump. Any questions on that? Any questions? Again, this is the hardest part of the entire day, of the entire week, is to understand this interpretation of the confidence level. So I'm going to pause a bit, make sure you can read this and understand it. Don't just memorize it. That won't help that much. But reading and understanding helps a lot. Okay, so I like to think of Gallup poll is definitely in the business of confidence intervals. They do that. They give a estimate of a percent, and they give a margin of error. And that gives you a confidence interval. 95% of the time, they're going to be right. Right meaning their interval contains the population proportion. 5%, their news is wrong. Any questions on that? Okay, is there any words that we need to use in the interpretation of the confidence intervals, like in the conclusion? The important thing, and this is going to be hard to tell you, is you need to understand it. If you can understand, the words will flow. But notice a couple things, is that, see the word population proportion? So you need population proportion, but if the confidence interval is about a mean, which we're about to do, it'll be mean, not proportion. Does that make sense, Morgan? Okay. The other thing is this won't be enough for the project. For the project, I want full paragraphs about it. So I want to talk about, well, is it okay to be 95% confident? Is it okay? What are the ramifications if Gallup is wrong? Okay. They lose their reputation a bit, but what else might happen? Okay. People are going to make decisions after seeing this. And then what poor decisions are going to be made because they saw this interval? If they were wrong, they're probably right, but they might be wrong. Does that make sense? So in your project, you have a lot more to do. Any questions on this? So part of your project one, a big, huge part, is to do a confidence interval. It turns out you're going to be doing 2 questions, not 1, or 2 populations, not 1. But this is going to give you the idea, at least. Any questions so far about this? Okay, now let me give you another example. And this next example is going to be about means instead of proportions. So let's do it. By the way, this was Gallup. Gallup wants to be 95% confident. What if it was, say, National Enquirer or some, web blog? Do you think they need 95%? What do you think? Yeah, they don't care if they're 95% confident. Okay, they're going to use a much smaller level of confidence than what Gallup used. One more thing to note is that if you go to, and let me draw this actually before I erase this. If we went instead of 95%, if you went to 99%, that means we're way out here. You see that? Because 99% needs to cover a whole lot more area. So if you change it to 99%, you can be more confident. That sounds good. But then your margin of error is going to be much bigger. So instead of maybe 37.5 to 42.5, you might say, well, we can be confident that we're somewhere between maybe 25% and 55%. So yes, you can be more confident, but then your percent's going to be like worthless. Does that make sense? You could also be 99%. If you're 99%, say you were, instead of 95%, let's say you were 80% confident. Well, then 80% of the curve might look like that. And then you could actually have a much narrower margin of error, a much smaller confidence interval, which is good because you can be more accurate, but you're more likely to be wrong. So it's a trade-off. It's a trade-off for the percent chance of being wrong with how wide your confidence interval is. If you want to be right and have a narrow confidence interval, it turns out the only way to do that is to make sure n is larger, bigger sample size. And that has to do with this formula right here. Sigma sub p hat has n in the denominator, which means that if you increase n, your standard deviation goes down. Do you see that? Do you see the math there? And if your standard deviation is down, your normal curve juts up right in the center, and everything is real close. So the only way to have both a better confidence interval, confidence level, and a narrow margin of error is a large sample size. But that takes more work. So there's always some problem, right? If you wanted to do, say, a 10,000 sample, imagine how much work that would take. Okay? And for Gallup, work is money. For you guys, work is time. But either way, it's harder to have a bigger sample. Notice, by the way, they did a sample size 1,500. You need over 1,000 for sure to have good results. And you know from your project, for example, over 1,000 is a lot of work. So that's one of the big reasons why I tell you have to do quantitative, is I don't want to make you do 1,000 surveys. Any questions so far? Okay, now I'm going to erase this. And we're going to do another question. So let me pop in the next one. Okay, so here is the first one with this type of problem. Okay, so it says you're interested in estimating the mean amount of time that LTCC students spend on campus on days they do go to campus. Okay, now you guys don't go to campus that much because you're online. Some of you never go to campus. But let's just say maybe the ones that aren't online students to make life a little easier. Based on prior knowledge, you know the standard deviation for all students is 1.3 hours. Okay, the one thing about this, I'm not going to do this whole problem, but I want to kind of discuss it a little bit. See this based on prior knowledge, you know the standard deviation for all students? That typically never happens. You're not going to know the standard deviation for all. But if you do know it, then we can draw a curve. So then we could draw our curve. Like so. And we know the standard deviation, so there's a normal curve we know. And if we wanted a confidence interval for the mean, we're going to get the mean of all these numbers, and that's going to be x bar. And if we had a 90% confidence interval, it's going to be a little narrower than before. So that means 90% is in here. Any questions on this? Okay, so 90% is in here. So now the question is, how do we get a confidence interval? And what I want to do is I'm going to tell you that we know the standard deviation for all students is 1.3 hours. That'll never be true. You're not going to know the standard deviation ever. So I'm going to kill this piece. I just want to show it to you to tell you what happens if you know it. If you don't know it, it turns out that we have to do an adjustment. The adjustment is this normal distribution is not quite normal anymore. So if you have to guess at the standard deviation, there's going to be a little extra error. There's going to be a little extra error. And it turns out the distribution, because of that extra error, will no longer be normal. The good news is that it still looks pretty normal. If you draw a picture, it's going to look like the one I've got right here. And the other good news is the calculator can handle it. The math is brutal. We're not going to do it in this class. So it turns out that with the adjustment, because you don't know the standard deviation in the real life, we're going to be using not the normal distribution. We're going to use a distribution called the student's t-distribution. And it's some kind of cool history. The guy who developed this, he was obviously a statistician, but he was working for a brewery company making beer. I thought I saw someone maybe drinking it. So he was working for a beer company, and he noticed that using the normal distribution made the confidence interval not work. That actually he wasn't getting 95% of his confidence intervals to contain the true population mean when he was doing beer tasting. And it wasn't just because everyone was getting drunk. Okay, it was because there was a math problem. And he actually came up with this new distribution called the t-distribution. Okay, you don't have to know the math of it because it's very intense. Even if you had 2 years of calculus, you don't know enough. But what you do need to know is it's called t. So we're going to assume that the distribution is normal. Now that is also a very poor assumption. So I'm going to let you know that there's issues with that, and we'll talk about that at the end. But for now, we're going to assume it's normal. Then what I'm going to do is I can go to my calculator. I want to show you how to do this. So let's do a new share, and we'll go to the calculator, and we're going to get a confidence interval. And the way I do that is I go to stat. I need to enter my data. So I'm going to go app, clear L1, enter. And then I'm just going to tell you, I know you can't see it anymore, but the first number was 2.5. The second number was 3, then 4, then 2, then 3.4, then 5, then 7, then 9, then 1, then 14, then 11, 4 and 6. I'm sorry, it's 4 and 5. Oops. 4 and 5, 6.5, and then finally 8.5. Then what I'm going to do is I'm going to go to stat, and I'm going to go to tests. And now the main thing here is we're looking at a t-distribution. That's why I made a big point of it. Because in the calculator, you need to know that. They use capital T, but you use capital or small, it doesn't matter, but the calculator uses capital T. And it's a confidence interval we want, so it's T interval. I'm going to hit enter on that one because that's what we need. Notice that this is different than a one prop zint because the survey question is how much time do you spend on campus on days you go to campus? All right, and the answer is not yes or no. The answer is something like 5 hours. So when we have a question that is quantitative, then we're going to use the T interval for a confidence interval. Then I hit enter. Now you have choices. You can go to data or you can go to stats. What is given here? Did I give you data or did I give you statistics? What do you think? You can put that in your chat box. Yeah, data was given, not statistics. So that means I'm going to go to data and hit enter on the data. Then it asked me for the list, and I popped it into L1, so I can go second one. Freak is 1 is fine. Sea level, in this case, we wanted a 0.9, 90% instead of 95%. Basically, I just want to let you practice changing the percent confidence level. Pay attention to it. Then I hit calculate. And there it is. We have about 4.1 to 7.4. So let me write that down. And now I'm going to go back to Paint so I can start writing down what I got. So hopefully you remember, if I ask you to use a complete sentence to interpret the confidence interval, what are the first few words? You should all know this. I don't see you typing it in, but you should be. So if I ask you to interpret the confidence interval, yeah, with 90%, this one's 90%, it's done 95% confidence, it can be concluded that the population mean number of hours that students, maybe it's LTCC students, spend on campus when they do go to campus, is between and 4.1 and 7.4 hours. Any questions on this idea? Any questions? Okay, the next one is use a complete sentence to interpret the confidence level. Now we're on level, not interval anymore. And that is like before. So then you would say, if many samples of, there were 15 of them, I think, 15 LTCC students are surveyed, then each would result in a different confidence interval. We could say 90% of these intervals will contain the true population mean number of hours that LTCC students spend on campus when they do go on campus. Any questions on that? Any questions? So again, if you did a different 15 students, and then a different 15 students, and a different 15 students, each time you can get a confidence interval using your calculator. Some of the time, you'll get the true population proportion in your confidence interval. Those are the winners. It means you got it. But sometimes you can be off. 90% of the time you'll be on, and 10% of the time you'll be off. All right, the last question is, if the distribution had not been normal, could we have still done this calculation? If the population distribution was not normal, could we have done it? What do you think? You should be able to answer this now. And no, but why not? And yes, but why yes? M. I'm not sure what that means. Inverse norm. Let's look at this. N was equal to 15. The sample size was 15. What's important about that number? Yeah, that's in particular, it's less than 31. So that means that the assumption was absolutely necessary. So this is probably a really bad study. The only reason why I gave you an example with 15 is it would have taken all day for me to type in all those numbers. I didn't want to waste your time. But in the real world, you better have at least more than 30 for sure, usually even more than that. Any questions on that? And remember, if it's a yes-no question, you got to check that NP and NQ are bigger than 5. Any questions on this example here? Okay, so let me do another example. It's going to look pretty different. And I need to erase all of this. And pop in another example. Okay, now let's suppose you want to construct a 90% confidence interval for the mean number of spam emails that come in daily per account. And you want a margin of error of no more than 0.8 spam emails. If you know the standard deviation of spam emails is 14, how many email accounts must you monitor? Okay, and by the way, when we say if you know the standard deviation is 14, a lot of times you do a little preliminary study and then you guess at it. That's when I say no, is you guess at it from a small sample. Because you never really know, but you can guess at it. All right, so what I need to tell you is there's a formula. And let me tell you the formula as it is. And it's an important little formula. Notice the first thing is the survey question is, how many spam emails came in today? And it's not yes or no. So because of that, we're going to go N is equal to Z times sigma over E squared. I do not expect you to immediately see where that comes from. Comes from the whole central limit theorem margin of error formula when you solve for N. I recommend putting it on your note sheet so that you've got it. So we need a few things. The first thing is I know a couple things really easy. Sigma guess I need a pen for this one. Equals to 14. Because it's given. E stands for margin of error. And the margin of error is 0.8. You don't need the plus or minus because we're squaring it, and squaring kills negatives. Z is hard to get. So let me show you how to get Z. Z is a bit of work. You need to draw the picture. So what we want is we want to say 90% is the confidence interval. So when I draw that, that's 90% area, right? How much area is right here? See if anyone can tell me. How much area is this left-hand side? If 90% is in the middle, how much is on the left-hand side? Yeah, 0.05. Because if 90% is inside, 10% is outside, half of that is 5%. What I want is Z. Z is down here. And it's a standard normal, so it's mean 0, standard deviation 1. That's what the Z stands for. And you remember in your calculator how to find that? If you're given an area, you want to find Z. So how do you find that? What buttons do you need? There's a special button that does that for us that we've done in a different chapter.
Second distribution. Second distribution. No.
So distribution and then
Second distribution. Infinite norm.
Yeah, this is going to be an inverse norm. Because when you're given an area and you want to find a value on the z-axis, that's inverse norm.
Yeah.
So let me go and share my calculator. Let's do it. Work. I think it didn't work. Let's try one more time. I'm getting click hard enough. There we go. So I'm going to go second distribution. I'm going to inv norm. The area now is 0.05. Mean is 0. Standard deviation is 1 because it's standard. Let's go get it. And you get negative. Everyone uses 1.645. The negative's not important because we're squaring it. So 1.645 rounded to a few decimals. So now we can actually answer the question. Let me write down Z. Oh, I forgot. I got to do new share. That's better. So Z is equal to 1.645. It's negative, but we're squaring. Don't worry about it. So we get to get away from that. So now we can say that N is equal to Z, which is 1.645 times sigma, which is 14, all divided by 0.8, all squared. Stick that in your calculator and tell me what it is. Put that in your calculator, and let's see if you can do that. and then pop it in your chat box. Just want to make sure you can do arithmetic on your calculator. Maybe I'll do it also as we're going. And what'd you get? So 1.645 times 14 divided by 0.8 all squared. I use Google Calculator and it's not giving me that. It's not giving me 13.9843. Yeah, I get 828.72. So be careful. So should we survey 828.72 people? What do you think? What's wrong with surveying 828.72 people? No, there's something out. There's something ridiculous about it. That's a hint. Let's suppose you have lots of money. You can do it. What's the problem? Still not seeing it? How are you going to survey 0.72? Doesn't work. Yeah, you can't survey 0.72, so you always round up. This is one of these you always round up. So you don't follow the regular rules of rounding, you always go up. And we're going to have 829. And that's how many we should survey. Any questions on that? Okay, I want to mention, I don't have time to do every kind of example. So I want to mention that this is the example for means. For proportions, it's different. For proportions, there's two formulas. If you know nothing about the population, it's going to be n equals 0.25 times z over e squared. So that's for proportions when you know nothing about the population. Any questions on that? Where z is that end norm thing we did. E is your margin of error. If you do know the population, or if you have an idea, that's a weird n. Let me fix that. So where did I get the 0.25? I will tell you. Let me write down where you did it, and I'll tell you, and then you'll wish you didn't ask. But I might as well tell you because it's kind of fun. So if you do have a preliminary estimate about the proportion, maybe you did the survey last year and you can do it now again this year, then n is going to be the preliminary proportion, PQ, times z over e. Squared. Where, by the way, q is 1 minus p. All right. So Linda, you asked where I got the 0.25. So if you look at p times 1 minus p times this constant, you get a parabola. And if you want to know where the vertex of the parabola is, it's where p is 0.5, and 0.5 times 1 minus 0.5 is 0.25. So you asked, so I'll tell you. You don't need to know that, but just in case you want to know, that's the reason. So it gives you the kind of worst case scenario is this 0.25 because the vertex of the parabola is the high point. So I'm not sure if you really wanted to hear that, but now you heard it.
Okay, so it's always 0.25.
when there's no preliminary estimate.
Okay.
Yeah, it's a formula. It's a good thing about math formulas, they don't change.
Okay.
If you do have a preliminary estimate, you put it into this formula, the second formula. I don't have time to do examples of everything. But again, in the long video, you get to see them, and they're in the book, and you'll have homework questions on them. So again, I try not to, take 3 hours for this webinar, because I think no one would show up if I did that. Okay, but hopefully you get the idea. So I want to give you the secret word, because it is now 7 o'clock. And then I'm going to talk, after the secret word, I'm going to talk a little bit about the project. So you're welcome to stay. So the secret word, do it in brown, I haven't used. So the secret word is margin, because we talked about margin of error a lot. Okay, and that's the secret word quiz for week 6, which you'll find in your modules. All right, so are there any questions before I move to talk about the project a little bit? Just a little bit.
Okay, this is really stupid, but on the very first question, you said NP was 1500 times 0.4 and NQ was 1500 times 0.6. Where did you get the 0.6?
Well, if 40% approved, 60% disapproved.
Never mind.
Got it?
All right.
Yeah. So Q is always 1 minus P. 1 minus 0.4 is 0.6.
Okay. Thank
You see? And that's in that little formula near the top. You see Q is 1 minus P. And that's a standard formula. We had it in last week, and now we're going to get it again. And guess what? We're going to get it again next week. This is an important one. The hardest part is to remember that if you have yes-no questions, we're talking P's and Q's. If you have means, which is quantitative, you're talking about not P's and Q's. You're talking about mu's. You're talking about over 30 if it's a quantitative. You're talking about over 5 for NP and NQ if it is yes-no question. So ask yourself the question, the survey question, and see if it's a yes or no, or if it's a quantitative. Any questions on that? Because if you get that part wrong, then you'll get the whole problem wrong, because you won't have it. It'll just be off. If you start working on the NPs, P's and Q's when it was supposed to be mu's and sigmas, nothing is going to work, and you're going to complain that I didn't give you enough information when I did. That's just a note. Okay, I want to mention a little about the project, even though we're not quite ready yet math-wise, but you're ready to start thinking about it. So for the project that you have, the idea is you are going to do what's called a hypothesis test and do a confidence interval. Confidence interval we now understand, but it's a little different. It's what a lot of you wanted to do for the project 1, but I told you couldn't. And that is, you're supposed to be doing a comparison study. So you could do, say, men versus women. You could do before versus after. But you're comparing 2 different things. It needs to be quantitative, and you need to have some kind of idea of what might be true. Okay, so for example, you might think that women have higher GPAs than men. Okay, and maybe women who are online students. I have no clue, but just say women who are online students. And then you can go and you can survey men and women, find out what their GPA is. And then you're going to find a confidence interval for how much higher women's GPAs are than men's. And you may find out, by the way, you're wrong. It might be men are higher than women. Who knows? Maybe they're the same. But you're going to make a guess, and that's called a hypothesis in this class. Unlike the last project, you don't need to worry about sampling technique. And in fact, it doesn't have to be a survey. You could collect data any way you want. So in other words, you could do a study that's more physical, where you're taking measurements. You could do a study where you're picking up data off the internet. What you can't do is do a study when you can find the population data. If you can find the whole population, it's not an okay study. Nobody does confidence intervals when you know the whole population. So if we knew the percent that like Trump, that approved of Trump in the whole country, there's no reason to do a confidence interval because you just know it. So it has to be something that you can't find out about the whole population. There'll be a lot more to it, but I wanted to get you started. And that's what you can be thinking about it. Each week I'll talk more. Next week we're going to have hypothesis testing, and that is going to tell you how you conduct a hypothesis test, how you make that guess and decide if you're right or wrong. This week is the confidence interval. The following week we're going to be talking about comparison studies. So again, we have 2 more weeks before we can fully go into the project, but I want to start giving you hints each week. Are there any questions about the project or about anything else about the class or about anything I did in this webinar?
For the t-interval under the stats on the calculator, what was the frequency that we used? I think I might have missed something there.
Okay, so let me do a new share so we can see the calculator. Much easier to have it there, right? Okay, so I go to stat, and I go to tests, and if you're going to get a t-interval, and enter, then freak is just 1. I think, let's try leaving it blank. I'm not sure if it allows you to do that or not. No, it doesn't. You have to put a 1. So that's just a 1. It's always going to be a 1.
Okay.
So that's easy to remember. It's always 1. And the idea is that tells you that for every item in your list, you're weighting it 1 time only, which is the normal thing to do when you have a list. Does that make sense?
Yes.
Yeah. You can set it to be some other, if you have a frequency table, which we're not going to do in this class, then it could be L2, for example. But in this class, it's always going to be 1. At least I believe so. Okay, any other questions? That's a good question, though, because, like, why did I put a 1 there? And it's just, that's why. It's just weighted as a 1. Okay, stats, by the way, I didn't show you one of those. Sometimes you'll be given the mean and standard deviation, and that's the mean and standard deviation for the sample. And then the sample size is n, and then sea level. So that could happen on problems that you may have to do in the homework or in the assignments.
So
that make sense?
In the homework,
Uh-huh.
it gave us the political candidate, a poll. It gave us the percentage of the people, but it didn't give us, it gave us a 99% confidence level. It did not give us how many people or the standard deviation. It gave us almost nothing. It's like,
right, you don't need much. So let me go to stats since I'm at the calculator. Let's go back to tests. So the first thing you're going to be looking at, that's going to be a yes/no question, right?
what? No. What? No, it's not true or false.
It's probably a yes/no question. It's probably political polls are usually yes/no, not always, but usually. Do you like this candidate, for example?
It wanted to know the percentage of the people that would support the people. So yes or no. Do you like her or not? I guess, yeah.
You see, so that's a yes/no, because the survey question is, do you support the president? Or I'm not sure what it was, but it was support something, right?
Yes.
Okay, and that's a yes, I support, or no, I don't support. Do you see how that works?
Mm-hmm.
So then that tells you you're going to go to the one prop z int. That's the first thing. The x are going to be the number of people that said they supported them. So let's suppose they said 23% supported, and let's suppose the sample size was, I don't know, 1,100.
That they didn't give us any of that in this one.
I bet they gave you something. Do you have the question
Yeah,
in front of you?
I wrote it down. A political candidate has asked you to conduct a poll to determine what percent of people support her. If the candidate only wants 4.6 margin of error at 99% confidence level, what sample size is needed?
Ah, that's a totally different question.
I don't
That's
like
what
that
sample
question.
size is needed, not what is the confidence interval.
I don't.
So what sample size is needed is find n. N is a sample size, right?
Yes.
So now I'm going to go back to my paint, because I have it here. And we don't know anything about anything, right? All we know is margin of error, right? And confidence level, right?
Confidence level, 99, yeah.
Okay. So that means we're going to use this equation here.
N equals 0.005 times.
0.005, n equals 0.25, right?
No. Oh, I went ahead and did 0.005 because I did the. Oh.
No, 0.25.
Well, I was looking at the 0.99.
Well, we'll use that. So let me show you how to use 0.99. I'm going to draw a beautiful normal curve.
I don't think I can do
At least
this.
I'll try to make it beautiful. And 99% tells you that's 0.99. Is that clear?
I have that.
So that is, because you got the 0.005, and then this is z. How do you find z?
Yeah, and then I did that equation, and that came out to 2.5758.
Okay, good, because I have that one memorized. That's correct.
Oh, you.
What's that?
Nothing. It's just like,
I've been teaching this for 25 years. 2.5758.
5.8. Yeah.
Okay. And by the way, if it's for the computer, I would give even more decimals there. The more decimals, the better. Does that make sense? Just so you don't have round off errors. Okay, because it does make a difference actually. 2.
Over 0.4, right? Oh, okay. Never mind. Go ahead. Sorry.
Okay. So now we're going to go n is equal to 0.25 times 2.5758.
Okay. Times that.
Sorry, I'm writing it so it looks a little weird.
2 point.
Yeah, there's a point, you just can't see it. Let me make it dark.
Oh, okay.
It's there. Divided by, and what did they tell you the margin of error was?
0.4.
0.4%?
Yes.
So that's 0.004. Because remember, you got to turn it back to decimal.
Yes.
And square it. And that will give you a number and then round up.
And that's my standard deviation?
No, that's your sample size.
That's my sample size? That's how easy. I don't even need the sample or the standard deviation?
You don't have it. There is no standard deviation. There's yes, no questions.
That's exactly right. They don't give it to you. And I'm like, this is insane. This is not, okay.
They shouldn't give it to you because they said how many people. How many people is what is the sample size? Do you see? So the how many people is what is the sample size? That's a find n.
Okay.
And there's no standard deviation in this formula because it's a yes, no question.
Okay.
Okay. Whereas the example I just gave you, that one you needed it because it wasn't a yes, no question. It was a quantitative question.
Okay. Get ready for a lot of questions in the discussion.
Keep practicing. Watch the videos too.
I did. I watched the whole hour one.
Okay.
I have 6 pages of notes.
All right, because I did do one like this in the video. Do you remember?
What?
I did a problem like this on the video.
Not exactly like this, though.
I mean, it had different numbers, obviously.
The very last one was about that, but it even that one gave 0.5 visits for the physical therapist. It gave a number of. It gave a little more information, and I was like, okay, wait a minute.
Yeah, but this is how you do that one.
Okay, all right, I'll do it.
Okay.
I'll figure it out.
All right, and I do check the Q&A, of course. Okay, are there any other questions?
I have a question. So I was wondering for the midterm if you were going to provide like a study guide or something. So
Yeah, I would do a whole webinar on it, but since you're asking, I can share my desktop and show you where it is.
Yeah.
It's a little early now because you don't know the information yet. You know, we still have a couple weeks of class left before that.
Yeah, just so
I'll
I
tell you
mentally
anyway.
prepare myself.
So let me share that screen. So if you go to, I think it's week 8, is that right? Let me find it. Week 8, see midterm exam?
Mm-hmm.
There's all kinds of stuff I give you. So there is the, you don't get to see that one, that's not published. Sketch of the midterm. So this gives kind of what you can expect. There is just a minute. A practice exam, which I'm not sure if it's going to pop up because my computer's saying it's insecure, so you may have to click on it and then it'll open a Word doc, it'll open it up. And that's a practice exam. Then there is ideas for studying, and that should get you going. Is that kind of what you wanted, Stephanie?
Yeah, thank you.
Yeah, it's too early though because the exam has a lot of confidence intervals and hypothesis testing stuff on it. So that's 2 full weeks of material that you really aren't ready for.
Okay, thank you.
Other questions? Any other questions? If there's no questions, we can say goodnight. Oh, by the way, the webinar next week, we can't do Monday because I like to honor President's Day because that's a holiday. So we'll probably do Tuesday unless someone really hates Tuesday. But we'll probably do Tuesday because we did Monday this week and last week. So Tuesday seems right. That's one reason why I did Monday this week is because we can't do it next week. And Monday seems popular. But we'll probably do Tuesday so that you can enjoy the President's Day holiday.
Thank you.
Okay, well, have a good night. And for those who are watching this as an archive webinar, thank you. Don't forget to post on the Q&A forum. If you have any questions at all, I check pretty often. And until next week, we'll say good night.